Hello class, today we are going to learn about rational numbers. So our objective for the day is to learn to write rational numbers in equivalent forms. And the word equivalent forms just kind of means just another word for saying equal forms, just things that are equal, like 1/2 and 6/12. Okay, those are equivalent, those are equal. So we're going to talk about vocabulary. There's a couple different characteristics for rational numbers. The first characteristic we're going to talk about a rational number is just any number that can be written as a fraction. So any number that's a fraction where the numbers on top and the numbers on bottom are integers. Integers is a fun word. Integers are basically, if you think about a number line and we have 0 and we have all the positive numbers, 1, 2, 3, 4, so on, and all of the negative numbers, -1, -2, -3, -4, and so on. Those are integers. Now, if you had something like 1.5, that would not be an integer. It's only the whole numbers, the positive and negative whole numbers. So 0, 1, 2, 3, 4, -1, -2, -3, -4. Those are integers. Okay? So with a rational number, you have to have an integer. So something like this, -3 is an integer, and you could put 4 on the bottom. That is a rational number. 2 and -7 is a rational number. However, something like 2.5 over 3 would not be a rational number because 2.5 is not an integer, it's a decimal. So that's the first characteristic of a rational number. It can be written as a fraction. Now, we're going to talk about this idea of two numbers being relatively prime. So the goal of simplifying fractions is to make the numerator and the denominator relatively prime. So we're going to be simplifying fractions today. A lot of times when I was in school, what they used to call that was putting things in lowest terms. Okay, but and we're going to put the numerator and the denominator. So anytime you have a fraction, let's just say we have something like, let's say we have 7/8. The number on top, that is the numerator, and the number on the bottom is the denominator. Okay? So what we want is we want the number on top, the 7 and the 8, to be relatively prime. That means they have no common factors other than 1. Okay, so let's look at a few different examples. Let's look at 16 and 21. And let's just talk about the factors of 16. Well, the factors I know are 1, 1 and 16. 1 times 16, those are factors of 16. I know also that 2 goes into there. And 2 times 8. 3, remember when we talked about divisibility, 1 plus 6 is 7, and 7 is not divisible by 3, so we know that 3 doesn't go in there. 4, yes, 4 is a factor. 4 times 4, right? And notice that 4 times 4, it's 4 times 4, right? So at first it was 1 times 16 is 16, 2 times 8 is 16, and now we're to 4 times 4. Notice that 1 times 16, those numbers are kind of far apart. Like 1 small, 16 is big, right? And then we go 2 times 8, and the numbers get like a little closer together. 2 and 8 is definitely closer than 1 and 16. And then the last one is 4 times 4. Well, those factors are really, really super close together. Now that you know when you start and the factors are far and then they kind of gradually get really, really super close, that's when you know there are no other factors. So those are the factors of 16. 1, 2, 4, 8, and 16. Okay? Now let's look at the factors of 21. Again, you're going to have 1 and 21. Okay, we're going to look and see, is 21 divisible by 2? Well, no, 21 is not even, so it's not divisible. What about 3? Is it divisible by 3? Well, if we add these up, 2 plus 1 is 3, and yes, 3 is divisible by 3. So we know it's divisible by 3, and so it's 3 and 7. We check 4. Is 21 divisible by 4? No, it's not even, so it's not divisible by 4. Is it divisible by 5? No, it's not divisible by 5 because it doesn't end in a 0 or a 5. And then we go to 6. Well, 6 is an even number and 21 is not an even number, so we know that it's not divisible by 6. And now here we are to 7. So now we know that these are the only factors of 21. And if you see here, 1 and 21 are far apart, and then 3 and 7, they get a lot closer than 1 and 21. And then we checked all the other numbers in between. So we know that we have all of the factors of 21 here. So when we're talking about numbers that are relatively prime, we are comparing. And see, I noticed that they do have a 1 in common, but they have no other factors in common. So 16 and 21, those numbers are actually relatively prime. So if we had a fraction with 16 over 21, this would be a simplified fraction because these two numbers are relatively prime, which means they have no common factors other than 1. 1 is the only factor that they have in common. So you could say this fraction right here is in lowest terms, or it is a simplified fraction. All right. Okay, let's talk about two other numbers, and I'm just going to kind of make a little line down here to separate the two. Okay, let's talk about 12 and 15. Okay, so let's talk about the factors of 12 and the factors of 15. So again, I know that 1 times 12, 1 times 12 is those are both factors of 12. And then 12 is even, so I know that 2 is a factor. It's divisible by 2, and 2 times 6 is 12. And then I'm going to move on to 3. Well, is it divisible by 3? Well, 1 plus 2. If I add up these, 1 plus 2 is 3. 3 is divisible by 3. So that means 12 is also divisible by 3. So I know that 3 is a factor, and 3 times 4 is actually 12. And yeah, there, I think we have all of the factors. So if you look here, 1 and 12 are kind of far. This is a really good example. And then what happens, 2 and 6 get a little closer. And then 3 and 4, there's really no other numbers. So now you know that you have all of the factors of 12 listed. 1, 2, 3, 4, 6, and 12. So let's go to 15. So for 15, again, we're going to start with 1 and 15. 2 does not go into it. 15 is not even. 3, let's check that. 1 plus 5 is 6. 6 is divisible by 3. That means 15 is divisible by 3. And it's actually 3 times 5. And the only other number between these two would be 4, and we know that 4 doesn't go into 15 because 15 is an odd number, and for a number to be divisible by 4, it would have to be even. So, well, it has to at least be even, and it's not even. So here we go. We have all the factors of 15. 1 times 15, and 3 and 5. So if we look here, I do see that there is a 1 in common, but there also is, they have a 3 in common. So what this means is since they have this, they both have a factor of 3 in common, these are not relatively prime. They're not relatively prime. Sorry, that went off screen. And so what we need to do is we need to simplify this. Now, I know in your probably previous class, what you guys did is you had 12 fifteenths. And you probably went divided by 3 and divided by 3. And then 12 divided by 3 is 4. And 15 divided by 3 is 12, 15 is 5. Right? Now let's kind of look at and see what's going on with this. a lot of times in mathematics, and then this is the simplified fraction, and 4 and 5 are relatively prime because only 1 can go into those. But let's kind of see what's happening, what's going on. And when we have in 12, 15, sometimes in mathematics, what we do is we rewrite numbers. And so what I'm going to do is I'm going to rewrite the number 12, and I'm going to rewrite it with this number 3 that they both have in common. So instead of writing 12, I can write 3 times 4, because 3 times 4 is the same thing as 12. And I'm going to do the same thing for 15. Instead of writing 15, I'm going to write 3 times 5, because that is the same thing as 15. Now, what's going on? If I just kind of cover up this, what we have really is we have 3 divided by 3. Do you see that? 3 divided by 3. And what is 3 divided by 3? Well, 3 divided by 3 is 1. So we have this. So basically what you're doing when you're simplifying is, because this has this common factor, 3 divided by 3, that's really equal to 1. And 1 times 4 over 5 is just the same thing as 4 divided by 5, or 4 over 5. So you're really just canceling out 3 divided by 3, which is the same thing as 1. So 12 fifteenths and 4 fifths are, they're equivalent fractions. They are the same. So if we want to look at that and kind of like a pictorial of that, we have this right here, 12 fifteenths and 4 over 5 here. And so if we just go ahead and we have 12 of the boxes, or we have 15 boxes, and I'm just going to highlight 12 of them to just show visually what's going on here. Okay, so that's our 12 fifteenths. And I'm going to do the same thing over here with the 12 fifteenths. Okay, except now I'm going to put it in yellow. Okay, so right now I have 12 fifteenths here and 12 fifteenths here. But as we just looked at, we know that 12 fifteenths and 4 fifths, mathematically, we just proved that those are equivalent. Those are the same. And now we're going to do it visually. Okay, so instead of dividing this into 15 equal regions, what I'm going to do is I'm going to divide it into 5. So we're going to have 1 here, 2 here, 3, 4, and then this is the 5th one, and like I said, it's 4 fifths, so I'm highlighted only 4 out of the 5, and if you can notice, they're exactly the same area. Okay, so that's visually, those fractions are exactly the same thing. Now, when you guys do your homework and you simplify it, how I'd like you to show your work is, if we're doing 12 fifteenths, okay, and we know that 3 goes into both of those, what we're going to do is we're just going to cancel out the 3 in both numbers. So I'm going to cancel out the 3 and 12, and instead of writing divided by 3 like you used to, all we're just going to say is, okay, I know that 3 goes into both of these. Okay, how many times does 3 go into 12? It goes in 4 times. How many times does 3 go into 15? And it goes in 5 times. So our answer is 4 fifths. So in our class, this is how I would like you to show your work. When we start getting into more complicated algebraic, different types of problems, this old method of doing it, there's a lot of stuff going on, and it just gets too muddled and confusing. So this is kind of just a more efficient way of doing it. So this is the way I'd like you to do it and think about it in class, okay? So now let's do a couple problems. The first problem that we are going to look at is example 1A, simplifying fractions. Now make sure that as you guys are taking notes, that you guys are doing these problems in your note packets. This portion along with this portion, this is your ticket if you'd like to get into the 30-minute session, is just showing that all of this work is filled out. So whatever I'm writing down, you should be writing down as well, okay? And any questions as I'm talking, if you have a question, let's say here, you're like, I really don't understand how you wrote this. Well, then, you can just make a little question and be like, hey, ask